Hi everyone, and welcome to FSI session 308, Chase International, always on customer experience at scale. My name is Colin Marden, and I'm an AWS solutions architect. As an architect, I help AWS customers build secure, scalable, and reliable architectures on AWS. I'm part of the AWS team that's dedicated to JP Chase, and more specifically, their payments, merchant services, and international businesses. It's my second re:Invent, but it's special for me because at this re:Invent, I get to introduce you to Chase International, to their CIO, Paul Clark, and to Courtney Delatour, an executive director and engineering lead. Chase is a digital-only retail bank that launched around 1 year ago. And they're owned by JP Chase, the larger business. If you've not heard of JP Chase, they're a leading global financial services firm with operations worldwide and around $3.4 trillion in assets. They're a leader in investment banking, commercial banking, consumer and community banking for small businesses, financial transaction processing, and asset management. With that, let's take a look at the agenda for the day. So we'll start with a few introductions to our speakers and to Chase International. From there, we'll discuss customer experience and why that matters so much to Chase International, before we dive a little deeper into the architecture and exactly how the cloud has enabled them to move fast, but equally to stay secure. Finally, we'll close by walking through some of the key takeaways and challenges from the last 12 months of operation. So, why did JP Chase build Chase International? To answer that question, I'm joined by Paul Clark. Paul, can you tell us a little more about the JP opportunity in retail banking and exactly why you built Chase?
Yeah, thanks, Colin. Hi, everybody. It's nice to be here. It's my first re:Invent. I'm sure for those in the audience that are American, you're familiar with Chase, the brand and the bank. It's never been launched outside the US before. It had been considered, but it was not thought to be the right time. Launching a bank requires a lot of infrastructure. You have to build branches, you have to do a lot of brand marketing. It's very, very expensive. But however, you know, the world has moved on a little bit, and we're much more used to now working in kind of digital ways, and digital banking is becoming much more prevalent. If you're in the UK, we have banks like Starling, we have banks like Monzo. In Europe, there's N26. Over here, you guys have got Chime and Venmo and people like that. So people are much more used to it. And we saw this point in time as the point in time to launch a digital bank. You know, we have quite an advantage over the kind of newer kind of entrant banks, if you like, having the heritage of JP behind us and having that kind of weight behind us. So we set out to build a platform that would scale to millions of customers, would scale up and down as it was required. You know, AWS it was what we chose to do it on. And the reason we chose to do it, you know, was because to do it that way is because everybody uses digital. Everybody in this room will have a phone in their pocket. Everybody in this room uses apps all the time. And what we wanted to do was build a digital bank that would scale, but at the same time provide the best possible service. Because people don't compare banks, right? You don't compare your bank to your friend's bank. People compare their banks to the digital apps they're used to using, their Instagrams, their Facebooks, whatever your favorite mobile app is. And so we wanted to build a bank using digital-first kind of methods that would scale, that would give that kind of a wonderful service. And then, ironically, we decided to do it in the hardest possible way. We decided to launch it in the UK. And we decided to do that because for those of you familiar with the idea of do the hardest thing first, the UK is a very competitive banking landscape, and it has the most kind of competitive digital banks. It also has a very high bar when it comes to regulation. The Bank of England and the PRA and the FCA, who regulate us, is considered to be kind of like almost the gold standard, really. So if we could launch a digital bank in the UK, if we could make that successful, if we could do that in that regulatory regime, we kind of ticked a box that this thing would have legs potentially to get even bigger. So in building that bank, and as we set out to build it, we wanted to kind of create the best possible experience, as I've already said, but we also had to create a trust, right? Banks are in a kind of unique position, unlike the other apps that sit on your phone. We have all your money, and people really care about that money, and particularly care if they can't get their hands on their money. So we needed to build a bank that would scale, a bank that was easy to use, but also a bank that you could trust. And we needed to kind of do all that and make it frictionless at the same time because, back to that point about you don't compare your banking app to someone else's banking app. What you do is you compare your banking app to your favorite digital apps. But we have a balance we need to strike. At the same time as we want to make that experience as good as possible for you and as frictionless as possible for you, we have to keep the bad guys out because we've got your money. You don't want to let the bad guys out. So we really kind of focused on the customer experience and how we could use customer experience to build that trust with you and to give you a wonderful experience of banking. So for instance, every time you tap your card, you get an instant notification that you've used your card. And you might think, well, I've just used it. I know that I've just used my card. Well, that's not the point. What we're doing is we're training you in some way to kind of recognize that when your card is used, you get an alert. So if you were to get an alert, if you hadn't used your card, then somebody else must be using your card. So we can kind of build that kind of trust with you. We send you real-time push notifications. We do other things like we pre-auth you when you phone up. If you need to phone us up, we pre-auth you. So you phone us from the app. You're biometrically secured because you've just come in via your phone. You come through to the contact center. Courtney's going to talk a little bit about how the magic happens later, but we know it's you, and we can take you straight into the journey. If you phoned from something other than your phone, we'd send you a push notification to your phone and say, hey, this is you. In the same way as you get two-factor authentication when you're using Google to log in. And all these things help build trust and help build a frictionless experience. And that then allows us to kind of offer you more services because, we're building that relationship. Talked about kind of building a bank in the UK. It's a great place to start. I'm sure some of you look at kind of Jamie Dimon when he gives investor updates. You have an idea about how much we're spending. We're not building a bank for the UK. I think, we started in the UK, and that's definitely the plan. But to be sustainable as a bank, you have to kind of be quite a large scale. And now we have a big advantage here against the legacy banks because of the way we've set about building the bank, and Courtney's going to talk about that in far greater detail than I could ever understand. Because of the way we've built it, it means that we can scale it up, and the kind of marginal cost of adding new customers to that platform is quite low. So compared to the legacy banks, which might end up having kind of a system per geography, let's say, and then all the costs that come with that, if we do this right, and I believe we are doing it right, and what we should be able to do is scale the bank up into multiple geographies, scale the bank up into millions and millions of customers, and we should be able to keep our costs low because of the way we use the underlying platforms that support the way we built it. This will give us a much better cost-income ratio than the legacy banks, and really, really help drive profitability in the long term. So yes, we've had kind of a lot of initial input, or a lot of cash input at the beginning to get this thing set up, but really the kind of payback comes in the long term as we scale the platform on and on. We worked really hard to try and get everything on this slide to end in ility, but we couldn't work out how to do that for the last one, so apologies for not being able to do that. But these are the core development tenets, and it's not just for development, it's how we really think about how we build a bank from scratch. Now, if other people stood on the stage here today and talked about their wonderful startup or their digital company, they'd all probably talk about similar kinds of things, right? We want to make it really, really easy for our engineers to do the right thing. We want to make it really easy for our engineers to do what they're good at, which is creating IP, creating services that our customers love, and really kind of delivering value constantly. And we work in a very heavily regulated environment. We have a control environment which is there for all very, very good reasons, right? To protect us, to protect you, the customers, to protect the money, to protect our reputation. And what we set out to do at the very beginning was ask ourselves the question, how could we build a tool chains and our kind of automation that would allow us to really kind of manage that control environment in a way which is almost invisible to the engineers. So they can just get on and do their job. But in doing their job, they're doing the right things in the right ways to protect us, to protect the customer. And for us, it was about building platforms. And you hear the joke, it's turtles all the way down. Well, it's kind of platforms all the way down these days, really. So, we built a banking platform. Customers come on, they can kind of do their, I think you Americans call it a checking account. We call it a current account. They can come in and use their bank account. That's on a banking platform. It's powered by our developer experience platform that allows me to kind of build, test, deploy, operate my software. That sits, next to our observability platform, so we can keep an eye on everything that's happening. All of the output of that gets fed into our data platform. That sits on top of our kind of tech stack, our tech platform, which eventually at the bottom sits on AWS, that thing that scales up and down. And what we did here is, we tried to simplify it for the engineers that they could just get on and do the right thing, and we could then move at pace and at scale. We do somewhere in the region of about 4,000 production releases a year. We try to make it really easy for our engineers to do the right thing, deliver value constantly. The other thing to mention on here is that last point, low power distance. We're not talking about hierarchy, although within Chase in the UK, we do try to maintain a really flat hierarchy. So I sit out on the floor with everybody else. But low power distance means allowing the engineers to just be able to get on with stuff, self-serve. So what we don't want to do is create a series of platforms that everybody has to raise tickets for. We want the engineers to be able to get their hands on the tools so they can get ahead and they can then create the software that's required. So we have low power distance both in hierarchy and in how the engineers kind of go about their day-to-day jobs. And this isn't just for how we think about kind of writing code and engineering. This is how we think about everything. So when we think about resilience, both technical and business resilience, we try to kind of make sure that we can automate those processes and kind of get all those abilities in place. With that said, I'm going to hand over to Courtney. And Courtney's going to talk in a little bit more detail about all that happens, how all that happens. Courtney runs our engineering team at Chase. So
Thanks, Paul. Paul just mentioned a lot of platform teams there, and because one of my teams is called the platform team, it's probably good to explain which that one is. And it's a team that you might have heard referred to as a DevOps team, infrastructure, or cloud enablement team. So it fits into that kind of platform space. And one of the things that we're doing here is we're building a platform, and it's a product. So we're calling the teams platform teams because these are related to products. Products have customers. DevOps doesn't have a customer. It's a way of working. The cloud isn't a product. It might be Colin's, actually, but no. He lied to me. Right. So we have the cloud, which is a technology choice for us, but it's not a product. Our product that we're building is the engineers that are building the bank for us. So we need to empower them to be able to build great customer experiences with as minimal friction as they can. And one of the things that happens when you have a platform team or a core engineering team or an infrastructure team is it might be tempting to consolidate control into that one team and erode the low power distance. And that's because it seems to be an easy place to implement these controls and requirements. Imagine that you want to mandate that you have an 80% code coverage throughout your experience. This is great for the team who wants to have 90% code coverage. They can meet that requirement really easily. But what about the team who doesn't want to do unit testing at all? They want to do their testing through integration testing. Might not be something I would recommend, but they're not going to have any code coverage metrics that will feed into your system, and then you will have reduced their ability to do what they want to do. It's our job as the platform team to enable other teams to do their job and not to tell them how to do it. You've probably heard the term go fast and break things. Right? This is a fairly common thing around startups and moving on. But as a bank, and to maintain that trust that we have, that Paul was just talking about, we have to go fast, but we can't break things. So one of the things that we started with was coming up with our account structure. At the start, we knew that we were going to be building a new bank with a new way of working, new principles, and potentially even a slightly different culture than the rest of JP Morgan as a whole. So one of the first things that we knew we wanted to do was to separate out all of our accounts and our workloads. It's quite easy to understand that we'd want to have our services, our banking, our accounts, etc., in different locations. But we wanted to go a step further, and we ended up separating out so that we run our own Bitbucket instance, we run our own tool chain, we run our own observability stack, we run our own data platform. We own everything separate. And one of the main problems that you'll face when you're starting on this is where do you actually start on designing your account structure? You could start off with the AWS well-architected framework. So it's a great resource, and you can go into the finer details of the implementations that you might want to do. This might end up getting you towards analysis paralysis, where you're asking, do we want to have a singular account where everything is in one place, or do we want to have a cellular architecture where everything is isolated? But for us, we wanted to have a look at what the requirements of these accounts were going to be and why we would do them. For instance, maybe we want to have role-based access control for some accounts or dedicated access for others. Some of these accounts might need to have 3 nines of availability, or others might need 5. RPO and RTO. There's going to be some things that do need an RPO of 0, but then there's going to be a lot of things that can actually tolerate some failure. And in terms of failure domain, you might need to think, oh, if we separate everything, nothing can impact each other if it fails. But then you're trading off economies of scale, and you're going to be paying a lot of money for compute and resources that you're not using. And I think given we're in an FSI track, a lot of us probably are regulated to some extent here. And so you need to think about auditability of your systems as well. You're going to be asked by your regulators to explain how things work. And where you draw the box around your accounts is going to impact how much you have to explain to them when they're asking you, how does this work? And also, if you create them too small, you're going to have to explain the relationships between all of those, which is probably just as big a work as doing it all into a single account. So what we have here is we have the internet edge, which is kind of like a DMZ. It does the same things. It does load shedding when you have incorrect payloads. It does attack analysis. It does high-level authentication for requests before we dive into zero trust lower down in the core banking stack. In the core banking accounts, this is where we run most of the services that make the bank actually work and the customer experience associated with it. You have an account, we need to track the balance of that account somewhere. You have scheduled payments to transfer some money to mom. We need to run that somewhere. And we also have savings accounts, which deliver some market-leading interest rates on them. But they also need to pay into somewhere. Now, these two accounts that I've just described have to be highly available and have low latency, because when you're trying to pay for a train ticket home at 9 p.m. at night, you don't want to be waiting for your bank because it's not working. However, to the right-hand side of that, we have the analytics stack, or data platform. This data platform is allowing us to measure whether or not our market-leading interest rates are actually having impact on the customer experience. Are people actually enjoying having more money paid into their accounts at the end of the month? Probably yes. But one of the things there is that this doesn't need to be nearly as available or have as low latency as the other systems. Yes, if they're not performing well or there's something wrong, it's going to impact internal customers, internal users of that platform. But these customers are probably going to be more tolerant of things not working quite so well. And to the right-hand side of that, we have our observability platform, which is collecting metrics from all of the points throughout these other areas into a single pane of glass, which lets us know whether or not our internet edge, our core banking, and our analytics platforms are actually working as we expect them to. Linking all of these together, we have a set of shared services that run message brokers, distribute artifacts, and a few other common things. And that's on top of the JP Morgan infrastructure backbone, which is a direct connect between the two networks that we have. Once we've started on some accounts, we end up working out what's going to go into them. Again, AWS well-architected framework comes into play here. But if you're looking at this diagram, you're probably thinking, oh, that's pretty simple. Why am I here? And you can learn most of what's in this in the Associate Cloud Practitioner course, which I think you can actually get certified downstairs at the moment. We have public-private subnet pairs, and we run all of our workloads inside the private subnets. We use managed services as much as possible across these. For instance, we're running Kubernetes using EKS. And while we have several hundred EC2 instances running across all of our accounts, we only manage a number of these that's around about 10 or so. Like, we do manage and use managed services a lot here. We make heavy use of private links, as you can probably see going horizontally across here, to enable access for accounts to talk between each other. This is to allow us to manage access control, and it also means that we can create new accounts and connectivity patterns without having to worry about managing CIDR ranges. We can create as many accounts as we want and connect them however we want without planning ahead for this. And you can see even on the right-hand side of this diagram that we have a high security area where the only connectivity is via a private subnet, private link. And then for some areas, we don't even need to use direct connectivity through anything at all. We can utilize AWS cross-account access to mean that services can write data directly into the source where it's needed. And we'll touch a little bit of that, how we do that for logging a bit later. Then in analytics, in toolchain and other kind of accounts, we need to have the ability to let engineers show their accounts to people who are actually on their workstations, which is where the transit gateway and the backbone come into play to make this work. So we know that our success is going to be through our ability to innovate. You know, we're going to have competitive pressure that comes in. People are going to be coming up with new banking products all the time. Our interest rate may not be quite so competitive as it once was, but we're also running in a regulated industry. And regulators are going to be doing things in the interest of people outside of us. And they're going to be able to legally mandate us to do these things. And we're not going to be able to say, you know what, we're just going to deprioritize that because we want to implement this feature first. We have to do it when they tell us to. And you can see that some of these regulations are starting to come into industries outside of finance as well. You know, there's a lot of privacy-related things coming in the EU. We have GDPR. which requires us to be able to display the data that we have on any given customer, and if they ask us to delete it. And we have similar things coming in around the world, such as the California Consumer Privacy Act. Customers are expecting us to deliver them new value and new features all the time, while regulators are expecting us to be compliant with them. And they don't really necessarily care which one you're trying to do at the same time. This means that it's important for us to be able to respond quickly across all of our services and to go quick. To do this successfully, you don't just need organizational design, creating sympathy between people, processes, culture, and people all across the organization and teams. There's one thing that you need to do, even if you're doing all of those things perfectly, and that thing is actually build your code fast. If you try to build a bank in assembler, you're probably not going to get there very quickly. And in some cases, microservices might be a little bit closer to assembly than a lot of engineers would like to admit. So, when we turn to the contact center, which is something that Paul was describing before as one of our key brand differentiators and important aspects of what we deliver our customers, remember, we're a digital-only bank, so there's only two ways people can interact with us, through the app or by calling us. So this is really important for us to get right. Connect allowed us to build this channel in a really simple way. If you look at this diagram, you can only see that Connect is actually only one of these icons on here, but the rest of them are other AWS resource types. And the power really comes in to the ability to integrate Connect into this ecosystem. One of the things that we do for authentication when people call in is a feature which we call collect to call. I'm sure that you've had an experience where you've rung up your bank trying to answer a relatively simple question about your banking profile, and they actually ask you something more complex to prove who you are. So they might say, can you tell us how much you spent on the Tuesday of last week? Or how much did you have to pay off your credit card at the end of the month? Because we've got you in the app and the biometrics associated, we already know who you are, and so we don't need to ask these questions. What we do is when you click the button in the app to call us, we log into our IDP, create a short-lived token, and then once the call is connected to the contact center, we send this short-lived token via DTMF, which is the dial tone modulated frequency, and those are the sounds that happen when you press the keys on your keypad. Once the call is connected and those are sent, AWS Connect is then able to interpret those, call into our IDP, and it knows who we are within a matter of milliseconds. This means that once you've completed the IVR flow and you're talking to a real agent, they are able to have all of the information about you in front of them and are able to see that's relevant, including if you've been using our in-app chat feature. But we don't have to stop there. Once we know who you are at the start of this flow, we can dynamically change the IVR flow that you're taking. One of the common kind of cases that you have on this is when you have a fraud alert. And that is, if you've made a purchase that's slightly outside of your normal spending pattern, the bank will sometimes send you a message or give you a call and say, hey, was this transaction actually you? In our case, when someone calls up about this thing, we're able to look into your account, determine do you have any fraud alerts pending, and then direct you into a different IVR flow, which will connect you directly to the fraud specialist for you to have that conversation with them directly. In other situations, you might have to go through an IVR flow, get connected to an everyday banking consultant, who will then transfer you to your fraud specialist. But obviously, we don't always get this heuristic right, and sometimes we will connect people who aren't calling about fraud to a fraud specialist. In this case, the fraud specialists have also been trained to handle most cases, and they can probably help without having to transfer. But they can still do that transfer if they need to. And because the call center is one of the key differentiators for our proposition, we knew that we had to start training everyone on how this will work and build the muscle for this early. We started doing this in around about early 2020, in fact, which, as a number of companies experienced, brought with us working from home requirements and was a little bit of a surprise to us. It was no different with our contact center. And anyone who's tried to listen to a YouTube video from their remote desktop through their home speakers probably knows where this is going. Turns out, when you're trying to connect a soft phone through a remote desktop to another cloud service, the voice quality drops a lot. We were able to modify our flow, create a new AWS Cognito pool to allow call center agents to log in from their Chromebook, which we distributed to them so they could work from home. They were able to log in there and then connect directly to Connect without having to use their remote desktop. They could then open their remote desktop, use their normal applications on network, and then when a call was received from their soft phone, it would go directly from Connect to their Chromebook. And this dramatically increased the quality of the voice calls, as we know. We knew this quantitatively because we're sending a lot of our information from the contact center through to our observability stack. This includes the number of soft tokens that we've issued, the number that have failed to resolve, how many calls we've routed intelligently, customer and agent transaction records, and we've even included some code into our soft phone, which can track the amount of background noise and the packet loss in the call itself. By using Connect, we've been able to easily deliver a great customer experience to our users and some innovative features that you won't see anywhere else, and we've been able to do this with minimal engineering effort. But Amazon hasn't been able to turn everything into a managed service just yet. We do a lot of things with microservices, and we currently are running several hundred of these in production today. When I was starting my work at JP Morgan, I was going through the interview process. I was talking to an engineer called Alex, and he was telling me about the project, how it was greenfield, how the culture was great, how we were a startup, cloud native, all these great things. And one of the things that he mentioned was that we were building a microservice architecture. And being a developer, microservice architectures is something that I'm quite keen on. And I did ask him, why are you doing microservice architectures? There's a lot of things where a monolithic application can probably serve you just as well, and putting a network call in between those things isn't going to make things better for you. But Alex was able to answer me in a somewhat paraphrased thing here, saying that we're using microservices because it's going to empower our teams to operate independently with flexibility, but it will also give us consistency where it counts. When we're talking about a microservice, there's a lot more that goes into them than just code. And sometimes we might think about the jar file or a Docker image and say, this is a microservice. But really, it's a lot more than that. And we want to make sure that we're giving teams the flexibility and empowering them to make the choices that they want to do. They're able to use open source projects where they want. They're able to use vendor products if they want to as well. And if they want to go through the hassle of doing a commercial arrangement with them, which can't always be the easiest thing to do. We don't mandate any frameworks, or slightly customized proprietary ones. And we let microservice teams use cloud services in their microservice. For instance, if you're using Redis, you might want to use a managed version of that through Elasticache. You might want to use S3, KMS, or you might even want to go off and do something a little bit more crazy and use something like GroundStation. As a platform team, it's not our job to choose what people are using, and it's our responsibility to empower them to do that. But these cloud resources and the infrastructure as code that goes with them are part of the microservices themselves. This means that we have to have the code next to the microservice and not in a centralized cloud repository somewhere. We do have some common interfaces that microservices are expected to implement, such as structured logging, Prometheus for metrics, and there are some API standards around this as well. We request that everyone uses Swagger to define their REST APIs, Avro for event-based APIs. And the reason for this is while we do want to make sure that teams have flexibility to build what they want, that we are creating a cohesive ecosystem overall. It makes a lot of sense that people can do what they want in their domain context, but the power of microservices is in the relationships that are built with other teams. Along with this, Paul mentioned before that we have a you build it, you run it mindset. This means that teams are responsible for owning everything to do with their microservice, the database, the schema of that data associated with it. So as a platform team, we're empowering teams to choose what data they want to use and how to store it. They could, if they wanted to, run Postgres on their own pods and manage it, make all the backups, do all the compliance and all of that sort of things. They might take a step away and use RDS and configure that directly. Or they could use one of the paved highways that we have as a platform team, and they could use a Kubernetes resource that goes off and creates it all, scaffolds it for them, and they know everything is compliant. But the power is in their hands, and they're able to choose. As part of Build It and You Run It, they're also responsible for the SLAs associated with that code base. So we've just gone through Black Friday and Cyber Monday. It's the team's responsibility who are operating these services to be collecting the metrics, to know what's expected of their service when things launch, and to make sure they're able to cope with this. And having gone through this event, we went through it perfectly fine. A couple of teams made some adjustments to their scaling, but they were able to do that fine. With our microservice architecture that we have, we've empowered our teams to make their own choices, their own flexibility. Because they're able to use open source technologies, they can come in and they can use their industry-wide experience in our teams. And because of a couple of small interfaces that we request, there's a cohesive ecosystem across Chase International as a whole. But you have to build these microservices somehow, and then you have to manage them. If you're building a monolith and you had 200 engineers working on it, it might make a lot of sense to just have 5 people who are there just tweaking the knobs, making sure everything kept running fine, deploying it when there was a change that needed to be made, etc. But when you have 30 teams, 7 engineers on it, it doesn't make quite so much sense to have 5 of those engineers doing the same thing. So you need to rely on automation for that, obviously. When we're creating a microservice, we start off with what we call starters. These starters are kind of prepackaged recipes for creating a service. They're not going to stick there, they're not going to long live, and you don't have to fit into them. They're a library rather than a framework. These starters are actually managed by the microservice teams themselves. They go into a centralized area, and they're evolved in an inner-sourced model. The platform team that I'm on, we contribute to these as we would any other service, but it's important that we're not the ones mandating what those are. When we're talking about what the best practices are for a Java service, a bunch of Go developers aren't really going to be able to answer that question well. We also use Helm charts and Terraform modules, and in these areas, it's still the microservice teams who are responsible for these. As a platform team, and because we're working with these technologies a lot more often, we provide more input into these, but it's a consulting role, not one of ownership and control. We are, again, enabling our teams to make their own decisions. And when we get there, it's interesting that on this slide, that's one part there that happens once per service. So we don't need to scale that much. But everything else happens many times. And when we started Chase International, we started with the stretch goal of 1,000 releases per day, which is quite a lot, particularly since we had no services to release at all, so we couldn't manage that. And to be honest, we're still not close to that today. But what that statement does is it focuses your mindset and thinking towards what are the things that we need to do to enable that if we are able to do it. It means that we can't do things like have manual processes in the middle that's slowing things down. We can't have an approval that takes 2 days. There's no way you're going to get there. But in a regulated environment, such as we are, we need to have confidence that the things that are going into production are what we need. So we make sure that we have repeatable builds because we need to know what's in production. And if your build isn't repeatable, what you're going to find is that it works fine, and then at some point you're going to have to come back and go, actually, what was in that artifact that I just deployed? It's going to slow you down. And the same goes for the artifacts that are produced out of these builds. They need to remain immutable. Immutability sounds relatively simple when you're creating a Docker image or something like that. But it can come in interesting ways, and you need to think about this. So if you're deploying something using Terraform, you need to look at the modules that your Terraform module is referencing. Are you pinning them to an exact version, or are you using an approximate version? And you're deploying things by a pipeline. And if in there you have some templating and injecting environments from your pipeline, do you know what version of your pipeline ran and what the value of those variables was at the time that something went into production? And will you be confident about that in a year's time? To enable all this, you need to have good quality metrics about what you're deploying. I don't necessarily mean Prometheus metrics here, which are telling us how many transactions per second our service is getting, but we do need those as well. But instead, I'm talking about the code quality. What is the cyclomatic complexity of the code? What is the test coverage, if you're using that as something? What are the supply chain and static analysis results when you've been security scanning this? What are the results of the integration load tests? Are you doing chaos testing, which we've got on as part of this as well? And then once you've deployed to your production environment, you can still do more things and cover that, such as smoke test and canary releases. Now, the last thing on this step is once you've deployed, you need to have the ability to automatically roll back if you find something has gone wrong. A lot of engineers that I've talked to in the past have said, you know, our strategy when we release something bad is to fix forward. And to me, that's an incredibly scary concept. And that's because when I talk to people about estimating a piece of work, they often use things like perfect day estimates or t-shirt sizing or something like this. And these are assuming that you know the problem up front. Now imagine that you're trying to solve this problem at 2 a.m. You've got a whole bunch of stress because people can't buy their tickets home, and you need to solve it quickly. Instead, the better option in most of the cases is to roll back to your last known good version. And you need to have this ability. And you'll be noticing that I've been talking a lot about deployments. But there's another element here, which is that a deployment doesn't mean that anyone's using your service. You know, we've got a few people around here who are selling, vendor products to help us deploy and then release separately. And deployment is an engineering practice. Releasing is a business practice. And you need to separate these two things. And you can deploy 1,000 times a day and release once a week. And in summary, we have several hundred microservices that we release daily. So what does this look for an engineer on the Chase team? On the left-hand side, we have a fairly standard Helm chart. And I hope that everyone in the back can read that, but it wouldn't be a technology kind of discussion if we didn't put some small font on there and hope everyone can see it. And this Helm chart is for an awesome and amazing service that's been written by an amazing team. You can see here that it has a dependency of the awesome team starter. That is that the awesome team has decided this is what they want their services to look like. This is how they get reuse across all of the services that they're building. It might be that that awesome starter that they've used references the Chase International starter, or they might have gone their complete own way. Inside there, we can expect it to be defining all the resources that we expect to make a service run on Kubernetes: deployment, service, auto-scaling policies, authorization policies, etc. On the right-hand side, you can see a definition or an extract of our pipelines as code. You can see here, we're defining an environment-specific pipeline. This is going to be reused across the different environments. What it does is it sequentially applies some Terraform, does a Helm apply, and then runs a smoke test. And you'll notice that this looks like a programming language. In this case, it's JavaScript. And the reason for that is quite important. And that is that we've empowered our engineers to use technology that they want to use and to evolve the ecosystem. This wasn't produced as part of a platform. This was produced by an engineer who wanted to change the way that they were releasing. You can see here that we're using some variables that are coming from the pipeline and some that are presumably coming from a package that has been reused across them. And I think that one of the important things here with having this pipeline that's been defined in code and by engineers is that they were able to make that choice themselves. But how do we let them do that? Well, we need to have some guardrails in place to make sure that things are safe. Right? Here, we have a guardrail that prevents engineers from deploying Docker images that are coming from any random source. In this case, we only allow people to deploy from our internal repository and from ECR itself. And those are the actual EKS AMIs in that bottom one. Now, guardrails, I think, are a really interesting thing in our space. It can be really easy to go too far with them. And an analogy I'd like to use, which I don't really like analogies in general, but imagine that you're driving down a highway. You're doing about 60 miles an hour. There's 3 lanes. You can pick which one you want. And somewhere over to the side, you've got a guardrail that you probably haven't even noticed. And you're able to drive down that 60 miles, fine. You know what you're doing. You're fine. Now imagine that we start bringing these guardrails in closer. Imagine we put it right at the edge of the highway. Do you think you'd still be doing 60 or maybe 55? And if we keep bringing it in closer and closer, imagine that the car just fits in between them. You can't even open the doors. You're probably not going to be going much more than 5 miles an hour at that point. So guardrails are there in the case of a catastrophic error. They're not there to make sure that you do things exactly the same way or consistently or to keep you on the path exactly. And when we're doing engineering guardrails, we need to think the same thing. We need to trust our engineers. We're hiring great people, and we need to make sure that they have the ability to go where they need to go. In this case of this guardrail that we have here, people aren't going to hit into it very often. Doesn't mean that they haven't, and it's just something that happens as part of their process. Now, we can use these guardrails and keep them to the right-hand side. I think an important bit here is that this guardrail, we shift things to the right-hand side with these rails. And that's a bit different because a lot of what we hear today is we need to shift everything left. What we need to do is shift feedback left, not necessarily controls. If we were to shift this guardrail to the left-hand side, we wouldn't be allowing engineers to use Docker Hub or anything like that for their development. Take it to an extreme case with security scanning. If someone wrote some code that had a buffer overrun in it, and they weren't able to run that to see what the API was doing, it would be a terrible experience. What's much better is to say, you've written some code, it's got a buffer overflow, and you're vulnerable to it, but to not allow that to run in production. We want to shift that as far to the right as we can. So we want to protect what we really care about, and by doing so, we also want to make sure that people can go fast. So that's a little bit about preventative controls there. But here we come into what happens when you're running services. Things will go wrong in production. And they're not necessarily things that you can think of ahead of time. They're going to be things that go out, and so on. So we need to be able to see what's happening. Now, for our logging stack, which you can see on here, we've chosen to make sure that this is as reliable and available as possible. And to do that, we've again turned to managed services. You can see here we have a number of log sources all feeding into CloudWatch, which then gets synced into S3 via a subscription. And we can also see that our containers are using FluentBit to push to S3. What happens here is that with all of these sources, we're collecting them into a single place that's highly available and resilient. Now, in this bucket, we've got something that's slightly different than what a normal pattern would be. We care a lot more about who can read this bucket than who can write to this bucket. We have a lot of sources all sending logs in. And if they put something in there that we're not expecting, we can probably deal with it on the right-hand side. But we're secretly implementing another guardrail in here. And that's because we might end up logging PII in any number of ways. A team might enable a debug flag in production to try and debug and understand what's happening in their service. And that might inherently enable request logging. And you might get request headers in there, which might contain stuff we don't want to share people. It might be that an object has ended up in a stack trace, and that's logged in. Or maybe someone's just logged an object that has it in there. But we can't let that go in there, and we need to be able to support cleansing, which is where Log Guardian comes in. Log Guardian is a tool that was written by the observability platform team, whose role and job it is to sanitize this PII data out before it gets into the hands of any operators. So Log Guardian is subscribing to SQS queues, which are triggered by S3 event notification topics. It pulls those objects in, sanitizes them, and then pushes these into OpenSearch. This gives us a couple of benefits, actually. One, this is now a pool-based system. If OpenSearch is under heavy load for whatever reason, all that's going to happen is Log Guardian is going to slow down, stop pushing things into OpenSearch, and it's going to slow down on how fast it consumes things. All that's going to happen here is that our log messages will be slightly delayed getting into our OpenSearch and Kibana instances. They won't be lost. And eventually, once the OpenSearch cluster becomes more available, they'll make their way through. Secondly, it also means that we're able to scrub our indexes. So Log Guardian is built using a series of filters that look for known patterns of PII. Can't just get rid of everything, or then the logging system wouldn't be very useful. Right? So what happens is sometimes there'll be a new form of PII that comes in, and Log Guardian doesn't actually know that it's PII, so it makes its way through to our OpenSearch. With this model, we're able to purge all the OpenSearch indexes, update the Log Guardian rules so that it filters everything out, and then republish the messages onto SQS, causing Log Guardian to pull all the logs again, run its updated rule set, and then publish them back. So in this way, we're able to respond to developer errors or changes in PII. Fine. Behind this, we have some metrics. So we need to know what's happening on these systems and how they all work and how they're performing. You know, we talked about the internet edge and the latency requirements. So what happens is services are generating Prometheus metrics. They display those onto different ports as they determine. So Java services might do port 9090, infrastructure services might do 690, and then who knows what else. So again, we make sure that we're empowering engineers by using Prometheus operator and letting engineering teams who are responsible for the services defining how that those metrics are scraped. Some cases, these services might need a resolution of once every second to be useful, and in other cases, once every 5 minutes might be enough. Again, this is in the control of the team who's running the service. These Prometheus instances are actually running in the clusters that are next to the services. So you need to be able to log into the cluster and find it, which can be a little bit of a pain, particularly over kind of a distributed system running many Kubernetes clusters. So to make this a bit easier, we have a centralized Thanos instance. And this Thanos instance is federating all of the Prometheus instances that we know about. It's collecting them at a lower resolution and archiving that data, and then displaying that into a single pane of glass that everyone can use to get kind of a decent picture of what's happening over the entire estate. And finally, another part of observability is tracing. These logging and metrics are great for getting a high-level view of what's going on. You can set up alerts on metrics. You know, our response rate has changed. But what happens when a single thing goes wrong? So tracing, we're able to instrument a request at the moment it enters our system and follow that request all the way through the system that it's managing. At the moment, we sample 100% of these traces. And we do this because we don't know which requests we're going to want to know more data on and what to find. We do this using Jaeger, open tracing. We're looking into ADOT for Amazon Managed Services. And we store this again into OpenSearch. So we've been able to prevent some mistakes with guardrails. We've been able to get visibility into what's going on with some observability and detective. And as Werner said, everything's going wrong all the time. So I'll pass you back to Paul, who'll tell you a little bit more about what we do when things do go wrong.
I mean, this is great, right? Because I was going to talk about event response and what happens when something goes wrong. I think the gods are smiling on me. So, as Courtney already discussed, we kind of run you build it, you run it. And we do this for very good reasons, right? As we said, Werner Vogels once famously said, everything fails all the time. You have to kind of deal with it. And despite our best efforts and everything that Courtney's been talking about, incidents still happen. And we believe that the fastest way to shut down an incident and to ensure that we're kind of maintaining that kind of fantastic customer experience we talked about earlier about how we build trust is to have the experts, the people that built the service, deal with the alerts. And so that's exactly what we do. If you build a service, you own that service. If the service alerts at 2 a.m. in the morning on a Saturday night, you get the alert at 2 a.m. on a Saturday night. And it's incredible once you start putting your engineers on call, how quickly the quality of your services improves. So I can highly recommend it. However, we work in a very highly regulated environment, as we previously discussed. And at the point an incident happens and it escalates beyond what an engineer could just kind of shut down very quickly by dealing with alerts, we need to bring in an incident management team to deal with that. We have many stakeholders that need to be communicated to, both internally and externally. Our regulator, the PRA, the FCA, these people want to understand what's going on. And so we have a major incident management team. Now, the job of the major incident management team is not to fix the problem. The job of the major incident management team is to coordinate the response. And in coordinating that response, what they're doing is they're freeing up the engineering resource that we have to really focus on what the problem is and to make sure that that problem is shut down as quickly as possible. And then once the problem has been shut down, it's the job of the incident management team to make sure that the postmortems are run, the problem tickets are raised, and then crucially the problem tickets are shut down. We have a very kind of strict mindset on this one. When we identify a problem, we don't just fix the problem where it was. What we step back and we ask ourselves a question, are there any other classes or any other places where this could happen? What is similar to this? And we read across the estate horizontally and we say, well, if it could happen here, could it happen there? And we tend to broaden out our search quite a lot to try and find out whether or not an incident could happen elsewhere. And what that allows us to do over time, is to improve the quality of the platform for everybody. Incidents are going to happen anyway. It's really how well you coordinate your response to it. And we're just like everybody else, right? We take best practice where we can find it. We model ourselves roughly on how kind of incident responders happen to kind of real-world incidents. So kind of your fire brigades and your whatnot, who are dealing with disasters, how do they organize themselves? We tend to align along that. But the important thing here is have your expertise manage the alerts and get them on the call as quickly as possible. So we've talked a lot. We've talked about the culture. We've talked about how we build things. We've gone into detail about many of the elements of the platform, and hopefully there's a lot there for you to think about. I could read out all the bullet points on this, but it's probably as boring for you as it would be for me. So what would be easier would be for me to kind of just call out the things that, if you were thinking about doing this yourself, are the most important. So for me, it's about building the tooling, right? We keep talking about hiring great engineers and creating value for customers and building a bank that people can trust. To do that, we have to have an extensive amount of tooling to automate how we build, test, deploy, and operate software, and how we do that within the control environment we want, and how we do that in a way which hands autonomy to engineers. So do that. Start off with that. But you don't have to build the whole gold-plated thing in the first go. You have to build the first version of it that will support what you need. And as you iterate your platform, iterate your services, so you iterate your tool chains as well. And so all those things kind of move together. When you're doing that, optimize for self-service. You don't want to create bottlenecks where people are constantly blocked, waiting for someone else to do something on their behalf. As much as possible, what you want to do is kind of that low power distance thing. You want to kind of push responsibility to the people that are writing the code and getting things done. And then thirdly, the reason we do this is autonomy. We want to go out and hire the best engineers that we could possibly find. We want to bring them in, and we want to give them every opportunity to create great experiences for our customers. And if that is what we want to achieve, that autonomy, Well, we need to bring those people in, and then we need to get out of their way. Because by bringing them in and getting them out of their way allows them to do their work and to create that kind of wonderful experience for our customers, that platform that scales, that platform that we've talked about that can kind of build trust. And that's what we've been doing for the last 3 years at Chase. We launched back in September last year. We've already acquired over 1 million customers. We've got over 10 billion pounds in deposits. I think it's kind of working. I see a really kind of bright future for it. So that would be my advice to you. So they're the final words from me. I'm going to hand over to Colin, and I think it's going to close it out.
Try and keep my microphone on. Just a last opportunity to say a big thank you. Firstly, thank you to our speakers, Paul and Courtney, for making the time to tell their story. Secondly, to our audience. I'm sure many of you have travelled quite a long way to be here, so thanks for coming. And finally, to our customers at Chase International who make all of this possible. So please make sure to fill out the survey, and if you see any of us about throughout the event, please do make sure to come and say hi at some point. Brilliant. All right, thanks everyone.